Okay, welcome back to another disheveled devlog. I want to talk about some sort of optimizing stuff that I've done with my own game that I'm bringing up because there's kind of been a recent discussion between me and WooTBM about this kind of stuff. There is some stuff that we should be aware of with default RPG Maker that it does, as far as I'm aware, it uses a single core on the CPU and basically doesn't use any of your GPU. I think some pixie effects might use GPU utilization, but honestly, for what it's doing, it really does not take advantage of your GPU at all. So most of the game is going to be bound by a single core on your CPU, which is where we run into a lot of problems with RPG Maker, where we have games, we have PCs that can run, like the newest AAA games. We pick up, Joe Blow's RPG Maker game and we get 10 frames per second. Why is that? And that's because it's only using a single core. It's not really utilizing the GPU. And when you have a bunch of these lighting effects and weather effects and poor use of parallel processes and eventing and maybe way too many plugins and stuff, you wind up bottlenecking the game, not because of your hardware, but because of the engine itself. So I do want to talk about some things I've done to kind of smooth things out and try to optimize some things a little bit more. Here I was watching WooTBM's devlog on this stuff. And one of the things he talked about is that he's worried about leaving in debugging stuff. Now that may happen, but I'm going to show you how I've attempted to overcome this possibility. So number one is that I have a text box here to alert me that I have debugging stuff left into my game. There's nothing complicated behind this. All it is, it's on my intro event thing here. You can see right here, there's just a little thing that says, Nolan, please remove all the debug skills and debug hotkeys. Please delete any chicken stickies and this message. So that's just there to remind me, hey, you forgot some stuff. A lot of stuff I tag with this comment here, debug. And then for any other debug stuff, you might be wondering, what the fuck is a chicken sticky? That's the name I've just come up for them just now before starting recording this. Chicken stickies is what I'm calling these events that I've layered around, which are chickens. These are just chickens that I put comments in or debug information in. The reason why it's a chicken is because it looks so out of place in the world. It will catch my attention no matter what. And also, I know that this works because basically anyone who did my beta test and made it as far to find the chicken sticky, everyone interacted with it. And so I have chicken stickies kind of littered throughout the world, doing all sorts of different things. Again, mostly just leaving comments for stuff that I need to adjust or whatever. Some of them are important. Some of them are important, some of them are not. But anyways, you'll find chicken stickies laid throughout the world, and these are just there for debugging purposes. Now, I know that's not necessarily optimizing, but again, like I said, it's all kind of like technical stuff that I kind of group into the same thing. So I want to move on to another part that I think is pretty important. In fact, some folks might even know more optimization tricks than what I have done myself, but there is one thing in here that I do think is really cool that maybe you haven't considered and maybe you do want to apply to your own game for optimizing. So let's take a look at some of those things. So first is one of the more obvious thing is that using wait timers in your parallel events. So the thing is with parallel events is that they are constantly running this information in the background. And so if you're constantly having to check information every single frame, and obviously you're running more checks than is necessary for what you're trying to do, because obviously it's very unlikely, especially depending on the speed of your game, it's very unlikely that you are checking certain bits of information literally every frame, because it probably takes anywhere between 5 to 10 frames for your player to move from one grid coordinate to the next grid coordinate. Now, obviously, this is going to depend on whatever it is that you're checking, but obviously, most player actions are not going to be 60 frames per second. Their actions are not going to happen within 1/60th of a second. So that's why at the end, you'd put a small wait frame there. Now here, I would even say this is not the most optimized thing here. I could probably, for checking XY coordinates, that's what this is doing here. This is checking XY coordinates for the player. You probably don't need to check this every other frame. So this would be half speed. So this would be 1/30th of a second. You probably don't even need to do it that much, but any sort of parallel event at all it's important to consider how important is it for this parallel event to be checked. And if it's not very important, then maybe you want to reduce the wait time down. Later on, we're going to come back to the wait time thing. I'm going to show it used in like not quite so like one frame. Like I'm going to show where it's lower priority, so I have a longer wait time on it. So this is just something that you would do, is you'd consider like how important is it for this event to be checked frequently, I guess is what I'm saying. And obviously the longer the wait time on there means the less important it is. And I think that's important to consider when you're trying to optimize your game to reduce stutters. Another thing is to just, in general, try to avoid using too many parallel processes. If you have parallel processes such as running in your common events here, if you have many common events that are all like parallel processes that are just running constantly all the time, checking for information, that could obviously cause optimization problems, as well as just having too many on-map parallel processes running that could also reduce the performance of the game, obviously. Again, I think some of this information is stuff that I think a lot of us already know. So sorry if it seems like I'm preaching to the choir, but you know, I feel like it's important to reiterate that stuff because either we might forget, or there is a chance that maybe just some people don't think about that. They might not realize that. So yeah, so having too many parallel processes can cause lag. So it's just better to, if you can, try to put all the parallel processes into a single parallel process that's doing all the checks, if possible. Now, the thing that I wanted to talk about next is just loading things into RAM. Basically, by default, RPG Maker loads its content into RAM on the fly. Whenever you need a picture, it's going to, if it's never seen that picture yet on this map, then it's going to call your hard drive or your SSD. It's going to say, hey, I need this picture. And the SSD is going to take a moment to find where that picture is. It's going to say, ah, here it is. And then it's going to give it over to your RAM. That whole process, that whole handshake that just happened there, takes a while. And this is the kind of thing that you might see in like certain games where you will have like random stutters when you are like random major stutters when you're moving through the world. And that's because that handshake is happening where it's having to unload some information from the RAM, talk to your drive about getting that information, that drive handing the information off, and then finally it can render the scene. So while that whole process happens, the frame rate drops severely, and then it picks back up once everything is available to be used. Now, RPG Maker does something pretty similar. It will load it on the fly, but this can cause problems sometimes. For example, during an event, you might have some sort of sound that you need or some sort of picture that needs to load, and it always just seems to not happen at the right time. It seems to be offset by like a few seconds or whatever. I had some issues using this. I'm not necessarily recommending this plugin, but anyways, I'm just saying that's generally the idea here, is that it's preloading those sounds into the RAM, because when you load it on the fly, you have a moment of time that it's going to take going from the drive to your RAM. And also that's going to depend system to system, because obviously if someone has a faster hard drive or SSD, then you know, the delay may be negligible. But if someone's using an older hard drive or a very slow hard drive, then the loading time is going to be noticeable. This whole conversation actually started with my previous live stream that I did, where one of the games used a preloader. Now, I have some potential concerns about this. I haven't done any testing yet to see how it functions, but the problem is that it looked like the preloader is basically taking all the pictures and all the audio and just dumping it right into RAM. That could be a problem depending on the size of your game. If you have, I don't know, 4 or 5 gigabytes of pictures and audio, then that means you're basically dedicating 4 or 5 gigabytes of system RAM to your game. And while that may not be much, as most systems now are usually using 16 gigabytes of RAM, you also have to consider the fact that you have your operating system running. You may have other background tasks running, such as Discord or a browser open or whatever. So yeah, it just ups the requirements if you're dumping 5 gigabytes of data into your RAM. And let's face it, not all 5 gigabytes are going to be important. You may have a sound effect that only is used one time in one place in the entire game. So basically all you're doing is increasing the system requirements for your game artificially. Like I said, I don't know how that plugin works. Perhaps it's a little bit more nuanced and it would allow me to select what needs to be loaded. I will look into that at some point later down the line. But this is just one thing to consider, is that you have to load stuff into your system RAM, and you need to be mindful of what other people's hardware might be. RPG Maker tends to appeal to people who have lower end systems, so they may only have 8 gigabytes of RAM in their system, or less. God, I hope it's not less, but it could still be less. So anyways, that long ramble aside, is that I've played with some different methods of preloading and smoothing things out. One of the things that RPG Maker does is, like, whenever you load into a new map, it seems to take a snapshot of that map, if I understand correctly. I don't know why, but either way, it is taking a snapshot of that map, and it takes a moment for that snapshot to save. And while it's doing the saving, it's going to cause some lag. If you open up your menu, it's taking a snapshot of the current. This is actually how it applies the blur, from what I understand, is it's taking a snapshot of the current map, applying that snapshot that it just took as a picture, applying a blur to it, and then loading the window on top. And again, that's what creates an occasional lag when you're entering and exiting the menu in the game. Usually at the start of cutscenes, I'll preload a lot of information. I also have my own cutscene common event, and this cutscene common event is called every time at the start of a cutscene and at the end of the cutscene. You can see that there's a switch here that is used to determine whether it's the start of the cutscene or the end of the cutscene. And then we get into the preloader here, which is going to load a lot of the common images that I'm going to be using for every cutscene. Now, it's doing this with them at an opacity of 0, so it cannot be seen by the player while it does this. It's basically almost doing it in the background. So it just runs through all these pictures real fast to bring them into RAM, and then that smooths out the cutscene going forward. This is a little bit jank, and I have been trying to figure out better methods of doing this, because what does happen with RPG Maker is that it does unload stuff after a while. I think in order to really optimize the RAM usage, and I think that's because the engine is intended to be used for mobile devices or lower end devices, I think it's really aggressive on the culling of information in the RAM, which I think is maybe a little bit too aggressive, because it almost seems like after a certain amount of time, it will automatically unload content from RAM, freeing up extra space. And like I said, I feel like that's a little bit too aggressive, because despite preloading some of these images at the start of the cutscene, if I don't use some of these images until near the end of the cutscene, it's very possible that it will still have the image, like the image will disappear while it loads it into RAM and then appears. So it kind of creates this blinking effect with the image. So yeah, but that's one method that I've used for handling preloading to kind of smooth things out. There's also more specific preloading for each cutscene at the start of the cutscene. So that's specific to the event. So when I trigger the event that has the cutscene, it's going to run through a preloader super fast, loading any necessary assets that are important for that cutscene as well. Then the other thing is I have my map transition smoother. So since the beginning of my game, I've called this the Do Once controller. The name Do Once is a little bit misleading here, but this mostly comes back to my days when I used to make mods for The Elder Scrolls 4 Oblivion. Here's one of my Do Once controllers. And so basically what happens is, this is really thoroughly commented. I've gotten away from commenting things like that. Like, this winds up becoming really messy with comments like this. So having the dashes to separate like different sections is better. But either way, for this purpose here of me doing this little devlog, this works out really great. You can see clearly what's happening. So because it's a parallel event, first we need to hold the player in place because we don't want them moving around while the main loading is happening. It's going to wait a moment just to smooth things out. So like I said, whenever you load into a new map, RPG Maker takes a snapshot whenever you load into it. So there's a small wait here just to kind of gloss over, letting it take its time to do what it needs to do before the player can move. And then here you can see loading is done. So we just set a movement route with nothing on it. If you are not aware, if you have a movement route that is currently going on, like a player is going through a movement route, and while that movement route is happening, if you set another movement route before that previous movement route is complete, you will override it, you'll cancel it. So this movement route with nothing on it is basically canceling the infinite wait time here. Well, it's not infinite, but it's a really long wait time. And then we untint the screen. The screen tint would fade to black. I should mention this before it goes into the next map. So as you're transitioning from the old map, the screen will fade out. We'll transition to the new map. It's going to run through all of this stuff, and then it's going to fade the map back in so the player can see it. So this fade to black, run the events, fade in system here is to basically make it feel a little bit more smooth. Without that kind of thing, what happens is, even though the player can technically move right away, and it may seem like things are moving faster, it does kind of feel a little bit ugly because you get some, stutters while things are loading and happening. So basically all this is preventing the player from moving, preventing them from seeing the stuttering, which just makes the game feel like it's running smoother than it actually is. It's kind of like taking sandpaper and smoothing away those rough edges, smoothing away those little stutters to make it feel like it's playing a lot more smoother than it actually is. That brings me to the final point that I think is really important. Now, say, for example, like I had mentioned earlier, you don't want to have too many parallel events running on your map at one time. If you can, you'd want to consolidate as many of them into a single parallel event if you can. But sometimes that's just not possible. Sometimes you need to have separate parallel events running. But if you have lots of parallel events running, then that's going to cause performance problems. So what do you do? That's where event culling comes in. So RPG Maker does have culling. Culling is basically hiding things, making things invisible, stop running things, deleting things when they are not visible to the player. Like if it's not within the camera's view, if it's not within the camera's viewport plus a little buffer zone outside of that viewport, if it's not within that area, then it gets deloaded. RPG Maker does have this built into the engine. However, it only culls mostly tiles. It will cull sound. Events as well, and I imagine it probably culls animation calls as well. But if it's a parallel event, it doesn't matter where you are on the map. The parallel event will run no matter what. Now, say for example, like in my map here, this is an absolutely massive map. So if we zoom way out, like this is an absolutely humongous map. Say for example, like if we look over here, we have some bad guys over here. We have some enemies just hanging out right here. And all of these bad guys, well, they are, collision-based combat encounters. So these are all parallel events that are running. Well, why would I want those parallel events running when I am off way in the ocean, way over here, just, doing my own thing? There's no reason to have those events checking that information if the player is nowhere to be found. This is where my event culling system has come in. So basically, there is a JavaScript command to check whether something is visible to the camera or not. If there's a JavaScript command for that, then we can set up a conditional for that. And if we can set up a conditional for that, then we can change behaviors of certain things with my other favorite JavaScript command, gameSelfSwitches.setValue. This command is one of the most important JavaScript commands I have ever used in my game, and ever since I learned this command, it has simplified my workflow a ton. There are two JavaScript commands that I think are very important. Number one, this gameSelfSwitches.setValue map ID, event ID, SelfSwitch ID is important for many different things. If you are not using this, I really highly recommend you start using this. Basically, this is remote SelfSwitch setting. So basically, you can use an event somewhere else, like a totally unrelated, to set another event's self-switch remotely. So this event is controlling this event's self-switch. Now that I can set self-switches remotely for different events, all I need to do is be able to know whether I can see the event or not, because what I can do is this. So if we look at one of these enemies, we'll notice that they have the event tabs up here. So the main one is just the enemy operating as usual. There's this one, which is just SelfSwitch A, and it sets the event to be just action button based event. That's it. It's not a parallel event anymore. Now that I can tell an event to change its self-switch, basically tell the event, are you going to be a parallel event or are you just going to be not parallel event? Now all I need to do is determine whether that event is visible by the player or not, which is where the second bit of pretty important script comes from, which is not gameMap.event 2 is near the screen, or event number is near the screen. So basically, if the event is not, as this says here, near the screen, then do this. So now for every event that I want to control manually, I can set up a color. So basically here we have a conditional. If it's not near the camera, set the self-switch to A, which is going to basically disable the event. If it is near the camera, the else right there, then set the self-switch to false, turn it off, which basically brings the event back to being a normal parallel event. And then you have to define, because it's checking the individual event, these are all the enemies on the map, is basically what this is. So you have to define that for each individual enemy, which does take some time. I'm sure there's probably a more efficient way of doing this. But what I do like about this is that you can manually control what is getting culled and what is not. So basically what I'm doing is, at the cost of one additional parallel event, I am able to cull every other parallel event. So basically, I'm running the game at 1280. So as far as I'm aware, it's checking 640 pixels outside of the visible camera range. So it has quite the wide buffer around it. Yeah. So anyways, so basically, because there's such a wide buffer around it, that leaves a lot of leeway for optimizing this parallel event to take its time, to go slow and check whether the player is near the event or not. And if so, then you can turn on the appropriate switch to make the parallel process run accordingly, which is why this goes way back to the beginning of this whole video where I was saying you could use wait timers. This is not very important due to the very wide gap between the visible range of the camera and the buffer outside of it, which means because of that wide gap, I can allow for a 12 frame wait time, which really optimizes this parallel event. It's not running that frequently. This whole system right here dramatically has improved optimizing large maps that are running a lot of parallel events. It's not going to be a magic bullet for everything, but for things like this map here, which is very large and has lots of parallel events, or like Caldera Colosso, which again is a very large map with lots and lots of parallel events going on, this event color is huge in optimizing the game and really smooths the performance out. So use those scripts to your advantage. There's a lot of different things you can do with that to help optimize the game, or even just create interesting puzzles or whatever needs to be done. So thanks for sitting through this ramble. Thanks for sitting through another Disheveled Devlog. And I guess I will see you guys whenever next time is. Bye.